evening, NATA aspirants, those who are attempting taking the August attempt. We are back with our fast track revision series for NATA August attempt, and topic for the discussion today is time, speed and distance. And if you are new to the channel, please subscribe to the channel for the update that we are bringing the videos in next coming days. And if you, please like this video so that this can be helpful for other students as well. And to download the study material, click the link given below in the description. So let us start with the time, speed and distance. So the very first question, so the basic idea for time, speed and distance is time into speed gives us, product of these two gives us distance. Alright. So here in this question, Karthik has to cover a distance of 6 km in 45 minutes. If he covered one half of the distance in 2/3 time, what should be his speed to cover the remaining distance in remaining time? So total time for Karthik was 45 minutes and total distance he has to cover was 6 kilometers. So this time is in minutes and this distance is in kilometers. So let's convert this time into hours so that we have speed in kilometers per hour, as we need to determine the speed in kilometers per hour. So let's convert this 45, let's divide this 45 by 60. So that will give us 3/4 hour. So total time available to us is 3/4 hour, and of which 2/3 of the time. So 2/3 of the time has been spent, 2/3 of the time, that is 2/3 of 3/4, which is 1/2 hour has been consumed or has been taken by Karthik to cover half of the distance. So that distance is 3 kilometers. Half of this 6 kilometers, that is 3 kilometers. So he covered this distance at a speed of 6 km per hour. How did we calculate this speed? Speed is equals to distance upon time. So distance is 3 km and time is 1/2 hour, half an hour. So that gives us speed of 6 km per hour. And this was already covered. So now remaining time is 3/4 minus 1/2, that is 1/4. So only 1/4 of an hour is remaining, and remaining distance is 6 minus 3, that is 3 km. So this required speed will be, 3 upon 1/4, that is 12 km per hour. Again using the formula, speed is equals to distance upon time, right? So answer to this one should be 12 km per hour. So here what we did, let's recall it. We calculated the time in hours because the speed is in kilometers per hour, and then we calculated the time that has been used to cover half of the distance in hours, and with the help of that we calculated the distance that has the speed at which the distance has been covered, and then subtracted this distance from the total distance to get the remaining distance that we need to cover, or that Karthik needs to cover, and the time that is remaining with Karthik, right? So the distance divided by time gives us the speed, that is 12 km per hour. This is a basic formula and you just need to apply the formula here. Let's see the next question. Next question is, a plane flies along four sides of a square field at a speed of 200, 400, 600 and 800 kilometer per hour. So a square, if we talk about a square, it has all sides equal, right? So total distance, if plane covers the entire square, will be 4a is the distance covered by the plane, right? And the speed at which the plane covers this distance are different, right? So let's say if plane started from point A to B to C to D and D to A again. So the plane covered this A to B at a speed of 200 km per hour, B to C at a speed of 400 km per hour, C to D at a speed of 600 km per hour and D to A at a speed of 800 km per hour at a speed of 800 kilometers per hour. So we need to determine the average speed. So average speed is not calculated as sum of all individual speeds divided by 4. This is not how we calculate average speed, right? So average speed is always calculated as total distance covered upon total time taken. Total distance covered divided by total time taken. To cover the distance, right? So here we have calculated the total distance, that should be 4 times the side of the square, that is A, and to determine time we will apply the basic formula, that is time is equal to distance upon speed. So distance for a side is A and the speeds are given to us, so that will be A divided by 200 plus A divided by 400 plus A divided by 600 plus A divided by 800. So this is the distance in kilometers and this is the time in hours, right? Kilometer divided by kilometer per hour will give us time in hours. So the speed will be 4a divided by, let's take LCM 200, 400, 600 and 800. So LCM will be 2400. Now 12 times 200 gives us, so that will be 12a. Now 400 into 6, so this will be 6a. 600 into 4, so this will be 4a, and 800 into 3, that's why this will be 3a. So that is 4a upon 12 plus 6, 18 plus 4, 22 plus 3, 25, and this 2400 goes to numerator. So this is 2400 divided by 25a. So a gets cancelled and 4 into 24 into 100 divided by 25. So this is 4 into 4, 16, 16 into 24. So 16 4s are 64. 16 4s are 64. Carry over is 6. 16 2s are 32 plus 6, 38. So our speed should be 384 km per hour. That will be answer option D. Alright students, I hope this concept of average speed is clear to you all. Average speed is not sum of all speeds given and divided by number of speeds, but it will be some total distance travelled upon total time taken. Now let's learn the concept of relative speed. Let's learn the concept of relative speed. What is relative speed? When two persons or two objects are moving in same direction or in opposite direction, they experience the speed to be different than the absolute speed, right? Absolute speed is when one person or one object is at rest and the other one is moving, then that is considered as absolute. But in case of relative speed, what happens is, if you are moving in a direction and in the same direction the one more person is moving, then the relative speed that you will experience will be the difference of the two, but same would be added when the person is moving in the opposite direction to the direction in which you are moving. इसका एक एग्जाम्पल बहुत अच्छा सा है, जब आप ट्रेन में ट्रैवल कर रहे होते हैं, जब आपके सामने से आपके पैरेलल में अपोजिट डायरेक्शन से कोई ट्रेन पास होती है, तो यू एक्सपीरियंस द स्पीड ऑफ द ट्रेन इज क्वाइट faster. But in case when one train is going in the same direction as the train you are in which you are in, then you will experience the difference of the two speeds of the two as the speed of the other train, right? So here with this relative speed concept we can calculate this question. Here what is given, A and B are 20 kilometers apart. So this is point A, this is point B. The distance between these 2 points is 20 kilometers, and A can walk at an average speed of 4 km per hour and B at 6 km per hour. If they start walking towards each other, so towards each other it means they must walk in the opposite direction. A walks at 4 km per hour, B walks at 6 km per hour, and they started walking at each other towards each other at 7 a.m. when they will meet. So relative speed is sum of the two, that is 4 km plus 6 km per hour. 4 km per hour plus 6 km per hour is the relative speed. So relative speed is 10 km per hour. And when will these two meet? When they together cover this entire distance of 20 kilometers. So distance to be covered is 20 kilometer. Relative speed is 10 kilometer per hour. So time taken will be distance upon relative speed, that is 20 kilometer divided by 10 kilometer per hour. So that will be 2 hours. And 2 hours from 7 a.m. So answer should be 9 a.m. Alright students, let's see next question. Next question is, a boy goes to school with a speed of 3 km per hour, with a speed of 3 km per hour, and return to the village with a speed of 2 km per hour. If he takes 5 hours in all, then the distance between the village and the school is, so let this be village, this be school, and let this be distance. So when he goes from village to school, his speed is 3 km per hour, and when he comes back, his speed is 2 km per hour. So time taken in going from village to school will be distance by speed, that is d by 3 hours, and time taken when the boy is going from school to the village is d by 2 hours. And sum of these two times is given to us as 5 hours, right? So let's substitute the value and determine the value of distance. So that d by 3 plus d by 2 is equal to 5. So take LCM, 6 2d plus 3d equals to 5. So that gives you 5d equals to 5 into 6 which is D is equals to 6 kilometers. So answer to question number 4 should be 6 kilometer. Again, the application of basic formula, that is time is equals to distance upon speed, and you know the sum of these two should be equal to 5. Alternatively, we can also try this one, that time, speed and distance, this distance is constant when boy goes from village to school and school to village. So this ratio of distances is 1:1, and speed is given as 3:2. So the time should be inverse of speed in ratio, that is 2:3, and total of this is given as 5. So in actual it is 5, so multiplier should be 1. So 3 into 2 will give you 6, or 2 into 3 will give you 6 kilometer as the distance. This can also be done. Let's move to next question number 5. A is twice as fast as B and B is thrice as fast as, it should be fast, not fact, there should be fast, as C is. So A, B and C. So A is twice as fast as B. So we are talking about speeds, right? So if speed of C is 1, speed of B is 2, and B is thrice as fast as, if speed of C is, B is thrice as fast as C is. So if speed of C is 1, speed of B is 3. Now we can go by scaling, or we can directly go by write the ratio of speed of A, B and C, that because here in both the cases the value for C is 1. So this is 1, this is 3, this should be 2, right? A is twice as fast as B, not C. So that's the error. So A, B and C. So A is twice as fast as B and B is thrice as fast as C. So now we need to apply scaling, and scaling is applied in the column where we have two different values. So take LCM of these two, that is 3. So you multiply 1 to convert this 3 into 3. So multiply all the numbers in this row by 1, that is 1, and you multiply 3 here. So multiply 3 in all this row, so that is 3 into 2 is 6. So speed of A, B and C are in the ratio 6:3:1. That will be the ratio of speeds, and C takes 42 minutes, right? Then A must take time 42 by 1 or 42 by 6, because speed of A is more, and we know time into speed is equals to distance. So distance is same, and for A, B and C we know the ratios of their speeds, that is 6:3:1. Time is 42 minutes, so that distance should be 42. So this distance should also be 42, this distance should also be 42, and here the time will be 14, 42 divided by 3, and here the time will be 7, 42 divided by 6. So correct answer to this one should be 7 minutes. So make sure you do not commit this mistake, right? So here we applied ratios approach in this question. So this is a combination of ratio and this is the combination of ratio and time and speed and distance. Let's move to next one. Yogesh, before I started this streaming, NATA 2 attempt result was not out. But after this stream, if it happens to be, then our team will come back with another live session to inform you that result for attempt 2 is out. Right? So let's see the next question. And the question is, a train leaves Indore at 6 am and reaches Bhopal at 10 am. Another train leaves Bhopal at 8 am and reaches Indore at 11 am. At what time do the two trains cross each other? See here, we have train 1 and we have train 2 running in opposite directions. This is going from Indore to Bhopal. This is going from Bhopal to Indore. It leaves Indore at 6 am and it reaches Bhopal at 10 am. And this leaves Bhopal at 8 am and it reaches Indore at 11 am. So they must meet somewhere between 8 and 10. So the meeting time should be between 8 am and 10 am, right? But what will be that time? So that we can determine, let the entire distance between Indore and Bhopal be d kilometers. Then for the speed of train moving from Indore to Bhopal should be d by 4 kilometer per hour, and of Bhopal to Indore should be d by 3 kilometer per hour. So for first 2 hours before 8 am, it is only the train moving from Indore to Bhopal is running. So the time for 2 hours, distance covered by train 1 should be 2 into d by 4, that is d by 2 kilometer is the distance traveled. So this is the half of the distance that has been covered by train 1, that is the train moving from Indore to Bhopal at the time when the train from Bhopal to Indore just starts, right? So after this, the remaining distance is d by 2 kilometer, and the concept of relative velocity comes into the picture, that is d by 4 plus d by 3. So d by 2 distance is to be covered with a speed. So time will be distance upon speed, that is d by 4 plus d by 3. So that time will be d by 2, take LCM, that is 12. So that should be 3d plus 4d. So that is d by 2, 7d by 12. Let's simplify. This will be d by 2 into 12 by 7d. So d and d gets cancelled. So that is 6 by 7. 6 by 7 hour. So let's convert this hour. So this is definitely less than 1 hour. So after 8 and before 9. So after 8, before 9. So there are two close options, that is 8 am, 8:56 am and 9 am. So let's convert this 6 by 7 hour into minutes. So that is 60 by 7, right? So this should be somewhere 8:56. This should be 8:56 because there is no option that suggests none of these as the answer, right? So this d by 2 distance is to be covered by d by 4 plus d by 3. Take LCM, that is 12, that is 3d plus 4d, 7d. So that will be 7 into 2, 14, or you can say 12 by 14 or 6 by 7 hours. So after 8 it is less than 1 hour, so that is definitely 8:56. Let's move to next question. One local and another express train were proceeding in the same direction on parallel tracks at 29 km per hour and 65 km per hour respectively. The driver of the former noticed that it took exactly 16 seconds for the faster train to pass him. What is the length of faster train? Right. So let's talk about what is the concept of length of train. Right. Length of train is this, right? And whenever, irrespective of the trains are in opposite direction or the trains are in same direction, if the lengths of two trains are to be considered, we will always add the length. But here we have to consider the length of the faster train only, the driver of the former, that is local train. Local train का जो driver है, he observes that it took exactly 16 seconds. So speed of train 1 is 29 km per hour. Speed of train 2, same direction is mentioned here, 65 km per hour. So relative speed should be 65 minus 29, that is 36 km per hour. So with this speed, faster train crosses the slower train, and time taken is distance upon speed. So this time is given to us as 16 seconds, and the distance is nothing but length of train, because the faster train overtook, right, the slower train. So when did this overtaking start? So let's say this was the slower train, and as soon as this faster train, so this is the time at which overtaking starts, and when this faster train leaves the last bogie of the faster train, crosses the engine of the slower train, then so the distance that faster train covered is equal to length of the slower train. So the distance is nothing but length of slower train, and that is what we are asked, right? So this 36 km per hour, but answer is in meters per second, so let's convert this kilometer per hour into meter per second. That is, kilometer is 1000 meters and hour is 3600 seconds. So on simplifying, that gives you 5 by 18, and 18 is 2 times, so that is 5 into 2, 10. So length of train will be 16 into 10, that is 160 meters. So this should be the answer. Let's move to next one. Two trains of length 250 meters and 150 meters are running on parallel lines in the opposite direction at 52 and 32 km per hour. (250 meter, 150 meter), this is 58 km per hour, and this is 32 km per hour, going in opposite direction. So relative speed will be 58 plus 32, that is 60 plus 30, 90 km per hour. Or if we convert this into meters per second, so that will be 25 meters per second. This is the relative speed, and distance covered is equal to sum of the length of the two, because crossing will complete when this situation occurs, right? This is 250 and this is 150, so this is the length. So time is equals to LT1 plus LT2 divided by relative speed. So the time should be 400 divided by 25, that is 16 seconds. So 16 seconds should be the right answer here. Let's see the next variety, that is boats and streams. So in case of boats and streams, what happens is, one thing is called speed of boat, other is called river current rate, also known as the speed of stream. Whenever there is flowing water, so it must have some speed, right? So that is speed of stream or river current rate. All right. So, and if speed of boat is mentioned, it must be in still water. In still water, that is calm water, the water that is not moving, right? And upstream and downstream are the two terms. Upstream, when boat or person moves opposite to the direction of the flow, flow of river or the stream, right? And what about downstream? Downstream is along, when the boat or person moves in the same direction, of flow of river, right? So we denote upstream by U, downstream by D. So this U is speed of boat, let's say that be B, and this be C. So U is nothing but B minus C, and D is B plus C, right? So we are given here 7 km per hour and 13 km per hour, that U is 7 km per hour and D is 13 km per hour. So we need to determine B and C both. So let's add them together. So this is nothing but B minus C. This is nothing but B plus C. If we add together, we will get C cancelled. So 2B is equal to 20. That is B is equals to 10 km per hour. And as soon as I calculate B equals to 10, I have only one option, that is 10 km per hour, and C will be 3, because 10 minus 3 gives us 7. So C will be, or rate of river or speed of stream will be 3 km per hour. Right. But the question is the speed of stream and the speed of boat in still water is. So this should be, as of now we don't have any other option, but had we had another choice, say B is equals to 3 km per hour and 10 km per hour, then we would have marked this one, not this one, because earlier it is speed of stream, later it is a speed of boat. So speed of boat should come later, but as of now we don't have any other option, so we'll go with option A. Let's see one more question on boat and stream. A boat goes 40 km upstream in 8 hours and 36 km downstream in 6 hours. So upstream speed is 40 by 8, that is 5 km per hour, and downstream speed is 36 by 6, that is 6 km per hour. the speed of boat in the standing water or still water. So boat plus current is downstream, boat minus current is upstream speed. So let's add these two to get 2b equals to downstream plus upstream, or b is equals to downstream plus upstream by 2. So that should be 5 plus 6 by 2, that is 11 by 2 kilometer per hour, or nothing but 5.5 kilometer per hour. So that is the boat speed of boat. If we were asked about the speed of river, so that would have been 0.5 kilometer per hour, as downstream speed is 6, upstream speed is 5. 5.5 plus 0.5 will give us 6. 5.5 minus 0.5 will give us 5. Alright students, let's see one more question on boat and stream, so that if boat and stream comes into the actual paper, so you will be easily able to solve it. Because I have many times I have received this feedback that we are able to solve speed, time, distance question, but we are not able to solve boat and stream questions. So let's solve them here. A motorboat can travel at 10 km per hour in still water. So B is equals to 10 km per hour. It traveled 91 km downstream in a river and then returned to the same place, taking, it should be taking, not talking, it should be taking, altogether 20 hours. The rate of flow of river is, right? It traveled 91 km downstream in a river and returned. So 91 one way and 91 return. So total of 182 kilometers in 20 hours, right? So that B plus C distance is 91 kilometers. So distance is equals to speed into time, right? Alright, and this distance is 91 kilometer, speed is B plus C, that is 10 plus C into time T1, and then 91 is the distance in upstream, and that will be 10 minus C into time 20 minus T1. So let's equate these two. So we'll have 10 plus C into T1 is equal to 10 minus C into 20 minus T1, right? So that is 10 T1 plus C T1 is equals to 200 minus 10 T1 minus 20 C plus C T1. So this CT1 and this CT1 gets cancelled. This minus 10 T1 goes on the opposite side, becomes 20 T1 is equals to 200 minus 20 C. Let's T1 is equals to 10 minus C. So this T1 is 10 minus C. So 91 is equal to 10 minus C into 10 plus C, or you can put the value of C here to determine, right, to determine the value, right? So let's not go by this method, let's go by the options, because we know 10 plus C is into T should be equal to 20 minus T into 10 minus C, right? These both are equal. So let's put C equal to 3 here. So 10 plus 3, 13. 10 minus 3 7. So if it is 13, then this t will be 7, and if this t is 7, this will be 13 into 7. So my answer should be 3 km per hour. Do not go by this entire method, go by option substitution. This is what the message from this question is. Alright. Let's cover up the last variety, that is races. So though this has not been asked in NATA, but for a surprise, they may ask. So Rahil, when we talk about race, there is a start line, there is a finish line, and at least two competitors are there, right? So if they start from the same point, one of them will finish the race earlier than the other, then the winner will be the one who reaches first, who crosses the finish line first, right? Another possibility is the both runners reach this finish line at the same time, so that is called dead hit condition. So that is no winner, no loser, right? But there is another possibility, that how a person can beat the another one. So the person can beat another one by two parameters. One, the time, and the other is distance. So how do we calculate time? So let's say A is faster than B. So as soon as A reaches the finish line, after that the remaining time taken by B to reach the finish line is the time by which A beats B, right? Or the other possibility, as asked in this question, is uh, distance. So the remaining distance that the slower runner covers after the faster runner has reached the finish line is the distance by which faster runner will beat the slower runner. So here in this question we have Rahil and we have Pankaj, right? So time, speed and distance. So Rahil covers 1 kilometer, 1000 meters in 8 minutes, and Pankaj covers the same distance in 10 minutes. So definitely it is Rahil who wins the race. If it is in time parameter, so 2 minutes, Rahil beats Pankaj by 2 minutes. But when it comes to distance, so speed, here it will be 125 meters per second, and here it is 100 meters per second, or 100 meters per minute, sorry, minute, not second, this is minute, right? So after Rahil finishes after Rahil reaches the finish line, Pankaj covers the distance of 8 into 100, that is 800 meters. So he is still 200 meters short to the finish line. So Rahil beats Pankaj by 200 meters, right? So person can beat another one by the time measures or the distance measures. Let's see the last question. In a 1000-meter race, X beats Y by 140 meter or 14 seconds. So from here, what can we determine? X, Y, time, speed, distance. Distance is 1000 meters, right? So X beats Y by 140 meters. So it means if X has covered 1000 meters, Y must cover 860 meters, right? Or if both cover 1000 meters distance, so if X takes some time, then Y must take 14 seconds more, right? So what will be the X time over the course? So let's calculate from this part the speed of y, that is 14 seconds, y covers 140 meters. So speed of y is 140 by 14, that is 10 meters per second. So y will cover the entire distance in 100 seconds. In 100 seconds. So x will cover the entire distance in 86 seconds. Right? So answer to this one should be 86 seconds. So thank you guys. Thank you for tuning in. I hope you people enjoyed this session, and to learn more in for NATA aptitude part, do come back to the channel at the same time 6:45 p.m. tomorrow. We'll come up with another topic. Thank you. Thank you for tuning in.